The quest for energy efficiency.
Our objective is to demonstrate the differences between open, closed, and isolated systems by observing temperature changes in a controlled environment while engaging participants through storytelling.
Now, let's identify our materials. So we have here our 3 identical containers. We have 3 thermometers to measure our temperature. We have the hot water. We have the lid. Our paper tape to label our marker. And our insulated material. Welcome team! Today, we embark on an exciting quest to uncover the mysteries of energy efficiency in our world. We are scientists on a mission to understand how different thermodynamic systems behave in our battle against energy loss. Our goal is to find the most effective way to observe heat. So first, let's assign our roles. Mr. Kurt Galandas will be our data recorder, and I will be your explorer for the open system. Ms. Kathleen Vidan will be the explorer for the closed system, and last but not the least, Ms. Kate Oliverio will be our explorer for the isolated system. Now, let's fill our containers with hot water, our precious energy source. Each of you will handle your own system carefully. Great job! Now that we have our energy sources ready, let's now begin our observations. Okay, so first, let's label our container. Oh, so this is an open system. Okay, so I'm gonna place this container in the heat resistant surface, and I will see if how much heat escapes. Oh, hi!
Well. As our explorer observes, they are witnessing firsthand how an open system allows energy to escape freely into the environment. What do you think will happen?
Okay, so first, let us label our. Now, it's my turn. Let us cover the container tightly with a lid.
The innovator is using cutting-edge technology to minimize heat loss. How effective do you think this will be?
So let us now label our container. Now, I'm wrapping my container with an isolated material to keep it as warm as possible.
Wow, our engineer is working hard to contain the heat. Will their design keep more energy in? Let's find out.
Now I'll collect all of your readings. Now let's see how each system will be performed.
So now, let's create tables and graphs to visualize our findings. So now that we have our data, let's discuss what we have learned on our quest.
Let us compare temperature changes over time for each system. In the open system, the initial temperature is 50 degrees Celsius to 45 degrees Celsius. The temperature dropped by 12 degrees Celsius. In an open system, both energy and matter can exchange freely with the surroundings. This allows the system to lose heat more easily, leading to a noticeable decrease in temperature. While in the closed system, the initial temperature is 60 degrees Celsius to 53 degrees Celsius. The temperature decreased by 7 degrees Celsius, which is smaller than the open system. While heat can transfer to the surroundings, the lack of matter exchange helps retain some heat. And lastly, in the isolated system, the initial temperature is 60 degrees Celsius to 59 degrees Celsius. The temperature dropped by only 1 degree Celsius, the smallest change. This is because the system is designed to prevent both energy and matter exchange, minimizing heat loss. Discuss reasons for observed differences in temperature changes. In the open system, the moderate temperature drop of 12 degrees Celsius is due to heat being lost to the surroundings with no barrier to prevent this, and the possibility of evaporation or other interactions with the surroundings can further contribute to the heat loss. While in the closed system, the smaller temperature decrease of 7 degrees Celsius occurs because, although heat can escape to the surroundings, the system's inability to exchange matter helps retain more energy compared to the open system. And in the isolated system, the minimal drop of 1 degree Celsius happens because the system is insulated, preventing heat and matter from escaping, and any slight change is likely due to imperfect insulation or minor experimental factors.
The observation in this experiment illustrate the fundamental differences between open, closed, and isolated system. In the open system, the absence of a lid allowed energy in the form of heat to escape freely into the surroundings, resulting in the fastest temperature drop and visible water evaporation. For the closed system, the lid prevented the loss of water but could not completely stop heat transfer to the environment, leading to a slower but noticeable decline in temperature. Finally, the isolated system demonstrated the greatest efficiency in retaining heat as the insulation minimized energy in exchange with the surroundings. These results align with the definitions open systems exchange both energy and matter. Closed systems exchange only energy, and isolated systems ideally exchange neither. Limitations and improvements. While the experiment effectively demonstrated the principle of thermodynamic systems, certain limitations may have influenced the accuracy of the results. For instance, variation in insulation material, thickness, or imperfections in the container lids could have affected the rate of heat transfer. Additionally, the ambient temperature and potential drops in the environment may have impacted heat loss. To improve the experiment using more precise insulation materials, conducting the test in a controlled environment, and employing digital thermometers for more accurate measurements would yield more reliable and consistent results. Thank you!
To conclude our mission today, let's summarize our key findings. First is we discussed how each system behaves differently regarding heat retention. Second is how we reflect on how this experiment illustrates how fundamental differences between thermodynamic systems.
Thank you all for your hard work today. Remember, understanding these concepts can help us create more energy-efficient solutions in our everyday lives. Until next time on our scientific adventure.